there are three thread types in the RTSJ, but really there are more than threads. Now we call them schedulables. And we kind of had to abstract one level above threads because of those async event handlers that Doug talked about. And they're a pretty powerful tool. So a schedulable in the RTSJ is anything that implements the interface schedulable. So you can create any object. If you implement schedulable, you become a schedulable. And that object then, its run method, which you have to have if you implement schedulable, comes under the view of the scheduler and dispatcher. And so it participates in all the real-time activity on the machine. So regular Java threads, as Doug mentioned, that's where you do the non-real-time stuff. Okay, just like normal, we take our Java RTS 2.0 product. It comes from Java 5, the hotspot JVM from Sun. We take the big app server, put it on top, runs fine. Okay, so Java RTS is Java 5 to start with, plus. And all of that occurs in the regular Java threads. And then there's two other kinds of schedulables, the real-time threads and the async event handlers that have the no heap set to false. And here we're talking about latencies, max latencies in the 200 microsecond range. It's just a ballpark figure. And I'll talk about how we do that with garbage collection when we look at the real-time collector stuff. And then the no-heap real-time threads, where you get an order of magnitude improvement in maximum latency. And those are the no-heap threads and the async event handlers with no heap set to true. So you might ask, well, why don't I just do everything in no-heap threads? Because I get better latency guarantees there. And it turns out that the programming model is a little more difficult there. And it's more like trying to do things in C, where it's not quite as bad, but the memory management isn't quite as automatic as in regular Java. So it's a little more complicated programming model. Okay, now some details about the product. We have 60 priorities for both real-time threads and no-heap real-time threads in Java RTS. And these are full priority semantics. I mean, you can go home, you can go to the bank on these things. They really, really, really work. Right? In regular Java, priorities are not guaranteed to work at all, even by the spec. Yay. But these do. And the RTSJ requires us very precisely to talk about, in our documentation of our product, exactly how the dispatching mechanism works and how the priorities work and so forth. And of course, on a monoprocessor, they're perfect priority semantics. On an SMP, okay, then you have the same issue. You may have threads of lower priority running on another processor. At the same time, higher priority thread is running on a single processor. That's the normal state of the world these days. And to implement those, we use the almost off-the-shelf Solaris real-time scheduling class. We've actually modified it a little bit. So when you install Java RTS 2.0, you actually get two device drivers that you have to install in Solaris. And so the JVM actually talks directly to these device drivers to implement a number of really, really cool features. And I'll talk a little bit about that in a few slides, a little more deeply. Okay, Java RTS 1.0 and 2.0 are fully SMP capable. And in the real-time scheduling world, SMPs haven't been addressed that much. So some of the feasibility analysis stuff in the specification itself isn't well fleshed out yet for SMPs. But what we do in Java RTS 2.0 is we use the Solaris notion of processor sets and adding processors to and taking them out of sets. And we have some limited support in the JVM for assigning particular kinds of threads to particular processor sets. And
what is SMP?
Symmetric multiprocessing. In the So let's see. So okay, where was I going? No, processor sets, right? So in the VM as it comes in 2.0, it's very easy to assign no heap real-time threads to a particular processor set. And the way that we get our good latency numbers is we put a processor in that processor set. We set it to no interrupt so that no interrupt handlers are handled on that processor. They're handled on the other processors in the system. And then the VM takes care of assigning all the NHRTs we create to run exactly on that processor. So that's one thing we do. Now, JSR 282, which is the RTSJ 1.1, they're working on some APIs that allow you to bind particular threads to particular processors, or some notion of processor sets that's more general, that sort of spans the whole industry. And so when 1.1 comes around, you'll be able to actually take any particular thread and assign it to any particular processor on the machine. Okay, wait for next period, and in 1.1 this is going to be, we're going to add another one called wait for next release to generalize this a little bit. But this is a very, very important method in the RTSJ. It's the way you create a periodic process. And when you create one of these schedulables, you give it a set of objects, one type of which is what we call a parameters, scheduling parameters object. And that object can be of various types. One type is periodic parameters. So if you create a schedulable with an object, with one of in the constructor, and one of the fields is a periodic parameters object, that schedulable, either thread or async event handler, becomes a periodic process in the eyes of the dispatcher. And in that parameters object, you can set values like cost and period being the most important. And we'll talk primarily about period in that object today. Once this schedulable is created, and with this periodic parameters, what happens is that wait for next period becomes framed in abstract, physical, real time, external to the box. And wait for next period will return precisely on the boundaries of the period given to it in the construction of that schedulable. So for example, if you create a NHRT with a period of 1 millisecond, and you have a start time in there of, let's say, 1,000 milliseconds, then wait for next period, if it's called, it will block until millisecond 1001, and then it will return exactly on that boundary, and then also it'll return on when the time is 1002. So wait for next period is the method that gives you the ability to easily create a periodic process in the RTSJ and Java RTS.